Welcome back to Data Explained. Today, we're tackling one of the simplest ideas in backend engineering that quietly powers nearly every fast app you use: caching. The core principle? Keep the answer close and ready so your database doesn't have to redo the same work a million times. We'll see why this matters and how Redis turned it into a superpower. So picture this. A million people hit your homepage, and every single time, your app runs the exact same expensive query against the database for data that barely changes. The database gets hammered, every visitor waits in line, and you're literally paying to redo work you've already done. The obvious question is, what if you computed that answer just once, kept it somewhere fast, and handed the same copy to everyone else? That right there is caching. So let's pin down the definition. A cache is a fast, temporary store that holds the results of expensive work, so the next request gets the answer instantly. Three things to keep in mind. It stores the output of slow operations. It lives in fast memory like RAM, and crucially, it's just a copy, never the source of truth. Picture a busy coffee shop. If the barista ground beans and brewed a fresh cup for every single customer, the line would be out the door. So instead, they brew a big pot ahead of time and pour from it instantly, only starting a new pot when it runs low or goes stale. That's your cache. Querying the database every time is brewing per cup. The ready pot is the cache itself. Pouring a cup is a cache hit. And brewing again, that's a cache miss. Let's put that into a clearer picture. On a cache hit, your app asks the cache. The data's right there and it comes back instantly, no database involved. On a miss, the cache shrugs, so the app falls back to the database, grabs the value, and stores it in the cache on the way out. Same request next time? That's now a hit. What we just walked through has a name: cache aside. It's the most common caching pattern out there, and the logic is exactly 4 steps. Check the cache, return immediately on a hit, fall back to the database on a miss, and write the result back before responding. The payoff is in that last line. Every future request for the same key skips the database entirely. That's where the speed comes from. Here's that pattern in actual code using Redis. We ask for user. If Redis hands it back, we're done. If not, we query the database, then store the result with X3600, meaning it expires in 1 hour. That TTL is the quiet hero here. It keeps the cache fresh without us ever having to manually clean up stale data. Let's zoom in on that quiet hero. TTL, or time to live, is just an expiry stamp. Once it passes, the entry vanishes and the next read goes back to the source. Shorter TTL means fresher data but more misses, so it's always a trade-off. Eviction handles the other problem. RAM isn't infinite. When the cache fills up, something has to go, and the usual rule is LRU, least recently used. The idea is simple: keep the hot stuff, drop the cold. Now here's where caching gets genuinely hard. A cache is just a copy of the truth, and the moment the real data changes, that copy is lying to you. It's stale. So how do you keep them in sync? 3 common moves. Let entries expire on a timer. Write to the cache and database together so they never drift, or simply delete the key the instant its data changes. Each one trades freshness for complexity in its own way. Step back for a second, because caching isn't just one thing sitting in front of your database. It's layered all the way down. The browser holds on to assets on the user's device. A CDN keeps copies on edge servers near them. Your app layer, that's where Redis lives and where we'll focus. And the database itself keeps its hot pages in memory too. Every one of these layers can answer a request, and the closer to the user it gets answered, the faster everything feels. So now, the obvious question: what actually belongs in the cache? The sweet spot is data that's read constantly but changes slowly. Anything expensive to compute, things shared across many users, and small counters like sessions or rate limits. What you want to keep out are values that must be perfectly current, data that changes on every single request, sensitive information unless you really know what you're doing, and anything that's only read once and forgotten. Cache the hot, predictable stuff. Skip the rest. Now, where does caching actually sit in the bigger picture? Think of scaling as a ladder. Rung 1 is tuning your queries and adding indexes, make the work itself faster. Rung 2 is caching, which is what we're focused on here. Above that, you've got red replicas to spread the load, and finally sharding, which splits your data when nothing else cuts it. The trick is to climb in order. Caching is cheap, quick to add, and honestly, it often saves you from ever needing the heavier rungs. Before we go deeper, let's clear out some myths that trip people up. First, caching everything doesn't magically make your app fast. Stale data and misses can actually hurt you, so cache the right things with sensible expiry. Second, the cache is not your database. It's a temporary copy that can vanish at any moment. Your DB stays the source of truth. And third, it's not set and forget. TTLs, invalidation, hit rates, they all need tuning because a bad cache will happily serve wrong data at lightning speed. Speaking of bad caches, let's talk security because an unprotected Redis is basically a free buffet for attackers. Always require authentication, bind it to a private network, and encrypt anything sensitive before it ever hits the cache. On the flip side, never expose Redis to the open internet, never run it passwordless, never store secrets in plain text, and always set memory limits with an eviction policy. Otherwise, your cache will happily eat every byte of RAM you own. Now, once you start caching in the real world, you'll bump into the same handful of names. Redis is the in-memory standard with memcached as the simpler, no-frills cousin, and Valkey as the open-source fork that spun off after Redis changed its license. Then there's a whole other layer. CDNs like Cloudflare cache content at the edge. Varnish sits in front of your HTTP traffic as a reverse proxy, and the humble browser cache quietly saves you billions of round trips every day. So let's pull it all together. A cache is just expensive results parked in fast memory. Hits are instant, misses go fetch and store. TTL and eviction keep things fresh and bounded. Invalidation stays the hard part because you're always working with a copy, and the golden rule is to cache what's hot, stable, and expensive to compute. Not everything you can get your hands on. Now let's talk numbers, because this is where the whole idea earns its keep. Pulling data from disk or a database typically costs you somewhere between 10 and 100 milliseconds. Every single request pays that tax. Pull the same thing from a RAM cache, and you're under a millisecond. That's 100 to 1,000 times faster, and it's the entire reason caching exists in the first place. If this sparked your curiosity, the Data Explained series goes further. SQL versus NoSQL, indexes, ACID, sharding, and a deeper dive into caching itself. And a quick word of warning before you ship anything. An exposed Redis with no password is one of the most common breaches out there. Your cache deserves the same hardening as your database. You'll find both tracks over at dargslan.com/courses. Before we wrap, I want to hear from you. What's the worst cache invalidation bug you've ever shipped or inherited? Stale prices lingering after a sale ended, one user briefly seeing another user's dashboard, or that thundering herd of misses that took down the database at 3 a.m. Drop your war story in the comments. The messier, the better. And that's a wrap on the data foundation. We've covered how to store it, find it, protect it, scale it, and speed it up. 5 pillars that quietly hold up every app you've ever used. If this series helped things click, hit subscribe so you don't miss what's next, and swing by dargslan.com for the full library. Thanks for watching. See you in the next one.